Hi, welcome to the session Backtracking. Here, the backtracking is solving a computational problems using recursive calls with step by step. It finds a solution by building a candidate solutions by increasing the values with time. The candidate solution in the sense partial solution in the each step we are finding using the backtracking method. It removes the candidate solutions whichever partial solution does not lead to give the complete solution for the given problem statement based on given constraints. The backtracking algorithm can be applied to below different type of problems. One is the decision type of problem, which is used to find feasible solution for the given problem statement, and optimization problem is another type of problem which is finding best solution that can be applied to the given problem statement. And third one is enumeration problem, which is used to find the list of all feasible solutions for the given problem statement. Here we are having different applications using the backtracking method. One is n-queen problem, a night tour problem, third one is maze solving problem, and fourth one is Hamiltonian circuit finding in the given graph. The n-queen problem is defined as one of the a classical backtracking example. Here it is used to arrange n number of queens in a given n by n chessboard in such a way when we are arranging the queens should not attack each other when we are arranging in the same kind of row or same columns or diagonal wise. So when we are arranging the queens in different manner, the queens should not attack each other. And when we are taking only single queen, we will take the chessboard like n by n in the sense only single column and single row. So it is a very smaller problem. We cannot solve this by using the backtracking method. That means it is not need at all a backtracking method. When we are having the n equal to 2, we will have 2 by 2 chessboard. Here we cannot solve this because you look at that when we are placing the queen here and another queen you cannot place this in this second row or second column. So this is also we cannot do by using the n queens problem in the sense backtracking method. Then when n equal to 3 means again we will have 3 by 3 chessboard. In this also we cannot solve by using the backtracking method. Q1 you can place here, the Q2 you cannot place here, so Q2 we may place here, that Q3 you cannot place in any of the column or row in the third one. So this is also cannot be solved by using the backtracking method, but we can solve the n queens problem by having the n equal to 4. So we will go through that. So here the chessboard is given. If we are placing the queen here, the diagonal column can be represented here I minus 1 row and j minus 1 column. This diagonal place is represented as I minus 1 comma j plus 1th column, and this can be represented as I minus I row and j minus 1. This diagonal place is represented as I plus 1 comma j minus 1th column, and this can be represented as next row I plus 1 and next column j plus 1. This place can be represented as I comma j plus 1. So by for accessing these queens we can use this kind of position, that means using the column and row variable. Here the n queens problem can be solved by using different methods, two methods. One is we can place the queens in different columns starting from the leftmost column, this one, And when we are placing the queen in column, the placing queen should not attack by already existing queens. So when we are placing in the current column, we have to find a row for which there is no class. So we are going for column wise. So when we are placing the column wise, when we are placing in the single column, we have to check with all possible places in the different rows. So when we are placing the queen in these columns, it should not attack by another queens. So if it is not attacked, we can make that position as a safe position by marking that row comma column cell. If we do not find such row due to classes, then we have to go back by applying the backtracking method. So here that algorithm is given by placing the queen in the leftmost column. If all the queens are placed, n queens are placed, we can return that result. Otherwise, we have to try with all possible rows in the current column. As I told here, if you select the third column, then we have to check this first row. If it is not possible, if it is already queen is placed here, then we have to check the another row, is it possible or not. If it is also not possible, then we have to go for third row, right? So if queen can be placed in the safe position in any of the row, then we have to mark that position as safe position. Otherwise, we have to uh, make that particular row as a unmarking. That means it is not safe position. We have to go back to the step A by selecting next row. Okay, so if all the rows are tried, if unable to place any queen in the row, then we have to apply backtracking method by changing the position of that previously placed queens. And another one method is here, we can start with placing the queens one by one in different rows, and different rows in the by selecting topmost row. So here when we are placing the queen here, then if it is we have to check with all possible columns. If it is not able to place here, then we have to check the second column, third column, etc. If it is unable to place, then we have to apply the backtracking method. So here the if find the position in the current row and current column without clashing, then we can mark that row comma column as a safe position. If we do not find that safe position in the particular row, then we have to apply the backtracking and return the false statement. So here the uh, to fill the queen in the safe position, we have to use this particular place state is as leading to next recursive call, and it will return the particular state as a uh, safe position to make the recursive call. Here the when we are placing the queen, suppose in this place, we have to check the left side, right side, top, bottom, and diagonal, all diagonal positions. Is there any queen is there or not? If it is there, we cannot place that queen and apply the backtracking method. If there is the space available, then we can place that queen and return the current state of the board. So we have to do this by keep on calling that recursive call until we are finding the position in the current row. And if any current row is reaching the number of rows, that means when all the rows are explode, then if you place the queens, then that is successfully we placed all the queens in the board. If it is not, then we have to apply the backtracking, and we have to keep on continue the process. Then finally we can store that all the states and return that place the queen's position as a result. Thanks for watching.